Hi everyone, today we will try to solve some tree problems uh, from the SD sheet. So let's get started. So the very first problem that I have selected is the binary tree right side view, and the problem before that I am not picking up. In this sheet I will try to do it from the left view of the binary tree, right? First of all, let's consider a binary tree right side view which is not mentioned in the list. Okay, it is a medium marked question, and given the root of a binary tree, imagine yourself standing on the right side of it and written the values node. You can see ordered from top to bottom. So here in this case, suppose if you are standing here and if you see to your left, right, you are standing right to the tree and you are looking here, then you will be able to see 1, 3 and 4. That's why you need to return 1, 3 and 4 right here in the output. And similarly, if the tree is like this, 1 null 3, which is like this, 1 left child is null and right child is 3. And if you stand on the right of it and then you look at it, then the output should be 1 comma 3. Okay, now let's talk about a tree wherein we also have, let's take a example of our own. We will manipulate the same example given to us, and suppose it, let's try to make a new example of our own. Yeah, so let's say now you view this tree, and then you will be able to see this one, then this, and then this node will overshadow this one. So you will be able to see this first, and then you have to then you will see this one. So overall you need to return this, and this. So if we see that our priority should be we go to the right child first. First of all, we will take the root, right? Store the root value. Let's say this is 1, this is 2, this is 3, this is 4, and this is 5. So I have stored 1, and then I go to the right of it. So then coming to this root, I stored this as well. Then again I go to the right. So that here comes 3. Okay, now it is not having any right child, so the call is over here, and then also it is not having any left. Then we come back, then we try to go to its left child, and a thing to notice here is if the value of this level is already stored, so we would not update the value here. Okay, so in order to do this, let's see, so we will not take this value and we'll move to the right, and then we will have 6. So how can we achieve this thing, that we are able to store the right thing first and then the left thing? Here it is clear that we cannot do something like this, that the only go to the right child right child only, because in that case if we go to only right, we'll end up having 1, 2 and 3, and we will miss on our this thing, which is 4, by the way, which is 4. So we will miss on our 4. So this is not what we should do. Okay, and let me take out my pen and paper and think more about it. I'll try to manipulate the example as well. What if I have something like this? And now if I have right side 4, then we'll be having 1, 2, 3, 4 and 7. Okay. How can I achieve this? I know that for a given level, if values exist already, then I should not store any value. Yeah, so I can do a thing like for every level I store a value, and then let's say here for the zeroth level I store 1, then for the first level I store 2, then 3, for the level 2 I store in 3. Yes, we can do a thing like so. Let's consider this tree which I'm drawing right now. 1, 2, 3 and 4 and 5, then 6 here, and then 7, right? Then 7. Let me make it something clear. And if I do yeah, looks great. And here what we need to do is I'm saying that for every level, like this is level 0, let's say this is level 1, this is and this is having a level. So these are not drawn properly. I'll draw this thing properly. And here is another level, and then let's say we have something like this and something like this as well. So here is another level, here is another level, this is level 2, this is level 3, this is level 4. For the 0th level I'll be having 1. For the first level 1 I should have value 2, and for the level 2 I should have value 3, for the level 3 I should have value 8, and for level 4 I will be having value 9. So this will be my right view. If you consider the right view, then these are the values you should be having. Now I can think of it as a map, wherein I can map the values to the very first level only if the value for the level does not exist already, because here you can see on the level 1 5 also exists, but I don't want any 5 to be here. So I can check in the map if the key does not exist already. Like if level 1 does not exist, then only I should store a value. And also I should keep in mind that the first value that I store should be 2 and not 5. Otherwise we will miss out on 2. Right? So we should store 2. Now how can we store 2 first? We can traverse the tree and we can start from root, and then we can traverse the right child first instead of going to the left child like we do most of the times. We can go to the right child, and then we can also write a call for the left child, but that will be for later. And now one thing you may have a doubt about is, why should we do a left call? The thing here is, if we keep doing right call, like you can notice, if you keep doing right call, you will have 1, you will have 2, you will have 3, but you will not have 8, because you haven't made any right call. And also you can also not do, like, if right exists, then do right call, otherwise do left call. This also won't work. Why is that? Because let's say your right child also exists, but the left subtree is more longer. Let's say here you have something A, then you have B, and then you have C, and then you are having a child below it, which is D. So if you are having something like this in your code, that if only the right child exists, then only make the right call, or if the left child if the right child is missing, then only make the left call, this won't work. Because here, if you see, at this point your right child exists, so you will make a right call, but if you don't make left call, you will miss the later value, which is D. You will miss up on that, and you will also miss you will miss this value D, which will also be a part of answer. So what I am saying, that we need to traverse the tree. Let's say this is our tree, and I'm not drawing the whole example again. So we should go to the right child first, and store the values. If the key does not exist already, if the value for that level does not exist already, and if the level exists already, then we do not store anything. So what do? We are at root. We look in our map. If 0, so here the level is 0, here is level is 1, here level is 2. So we see if 0 exists, 0 level exists, no, then we can store a 0 to the value whatever it is, let's say 1, and then we go to the right child. We see a level 1 exists, no, then we add a level 1 and store the value of this node, let's say, which is will be 2, and then we again go to the right child. We see level 2 exists, no, so we'll end up storing a value for that node, whatever the value it is. I'm considering it to be 3, and then we can go back and go to the left child of it, and then here we see that the level 2 already exists in the map, so we will not update the existing value, right? And then we can go back, and then we make a left call. Here again we see that the level 1 already exists in the map, so we don't change anything. And what we can do is we can store these values in a vector 1 2 3 and return it as the answer. So I will now try to code it up. Let's before coding, just have a look at the problem constraints. The number of nodes will be in this range, will be this, values are this. So yeah, let's try to code this up. You can try using we can try using node, so that will be a pre-order. We will be processing our node first. We will storing our node value first. So let's say I'll call this function void traverse, that I'll use to traverse the tree, and then I'll be having a tree node star root, and I'll also be having an unordered map, which will store my int to int, and I'll call it MP. and of course I'll be also having a parameter for level which will denote the current level. So here, if the root is not there, if root does not exist, then I'll simply return. Otherwise, let's write the main function as well. Here we'll be creating an unordered map which will map to int with, that means for every level I'll be storing a value which will represent the value of the node which is present on the right part of the tree. And also I'll need a vector later, that will be my answer, and I'll be returning my answer at the end. But before that, I'll call traverse. I'll pass root, I'll pass the initial level to be 0, and then I'll pass an ordered map as well. So here like I said, I'll be processing the node first. So for this level, I need to check if this key exists or not in the map. If mp dot count this key, which is here in this case is level, if this level exists already in the map or not. If that exists, so then I don't need to do anything. But if that does not exist, like if not mp.count, then only I'll will push a value for that level. I'll do mp of level equals to my root value, and then what I'll do is I'll make a write call, traverse root write, and level would be +1, and also I'll pass the map, and similarly for the left call, and here I'll pass my okay, it is messing up something. Here I'll pass by reference. Okay, now this map has been passed by reference. Yeah, it looks fine to me. And then also, now I need to take those values from the map, like I showed here. I need to take these values from the map and put it inside a vector. So maybe I can try doing something like no, that won't work, I guess. So what I'll do is I'll make a vector and I will iterate through the map. I'll call it P as in pair, and for every pair its P dot second will have our value. So I'll push that into our answer vector, and then I'll try to run this and see if that works or not. Okay, let's see what is the problem. We are getting the opposite answer. Why is that? I called the right child first. I stored in the right value first, and if that key exists already, wait, should I wait? Let's say if mp dot find level equals to mp dot end, then only I should do something like this, right? Let's see. Okay, again there is a problem. Apparently we are doing these wrong we are doing something wrong with the calls here. We should be calling the left call first according to this question, or should we? No. We are doing right, but we are missing up. We are missing something here. Okay, let's see where is the problem. This order should be reversed, right? That is the only problem. Okay, I see. What's happening here is that the keys, we should be taking a ordered map. That should fix our problem, and also we need to change here it as well, and that's how our keys would get sorted. Yeah, so that was a problem. We need to take an ordered map. Why is that? Because if we take an unordered map, then it is not it's not mandatory that the keys will be sorted. And what do we want? We want that the value, the level 0 first, then level 1, then level 2. But if we take an unordered map, then what was that doing? Maybe, okay, let's try to submit this off. We got the unordered thing, right? Let's try to submit it, and maybe then we can also do it using unordered map. Let's try to do it through that as well. And for that, I think we will need no. Let's just experiment with it, and I'll just add unordered. Most probably it shouldn't work. That's what I am expecting to be. Let's run this and let's see what happens. So the level 0 will be stored later. Okay, let's submit it. Okay, it gave a wrong answer. Why is that? Okay, here it failed. So the tree here is 1 2 3 4. That is 1 2 3 4. This is the case that we are given. Here what would happen, that I've taken an ordered map, right? So, and I have pushed my so the node will be stored later on. So this will get stored first. So the level 2 0 1 2, level 2 will get stored first. Its value will be stored first, then level 1 will store 3, then level 0 will store 1. So we'll be having 4 3 1. But yes, 1 4 3 we got, but we got 1 4 and 3. So we came to know that in an ordered map it is not necessary if these keys will come in a sorted order. So like what would have happened in this example, that there would be a map that is an ordered map, and it will create keys randomly. Like here it will create a 0 key, then it will create a key 2 and store it value, then key 1, and we want the values. We will take these values and store it our vector, but that is not the desired order. We want the values to be sorted according to the level 0 1 and 2. So that's why we should take a map, right, not an ordered map. So that was it for the problem. Let's see the time complexity. Here what we have done is, first of all, we ran our traverse function, and in the traverse function we are traversing the tree. uh, so that means O of n for the traversing. So that means we go of n for traversing the tree, and then also for every level we are storing ones, right? So we do not need to multiply, but we can simply only it's an ordered map, right? And for every level, depending on the how many nodes are present at any level, what I mean to say is, consider a trees like that. Right. Also, move this code up. What I need to say here is that let's consider a tree like this, and then at every level what we are doing is we are traversing the tree. That's fine, that will be O of n, but at every node we are checking, we are running a mp.find. This will run at every node, right? So the time complexity for it will be of log n. That would result in O of log n. But considering there are we are finding in the map, and n is what? N is the numbers, n is the number of elements that are stored in the map, but map will only store the different levels, and levels are limited, which is equal to the height. So we will be having a log of h complexity, so we will be having at max, so let's say call it O of n into log of h complexity. For every node we are having doing a log of h operation, that is fine, and we can just ignore the insertion complexity, because that will only happen only h times, right, at every level. So considering the height to be h, let's say there will be h level and there will be h insertions only. So let's say so we can neglect h. So the time complexity becomes O of n for traversing, then O of log into O of log h for the map find, and also here we get different values from the map itself. So also we can add mp of O of h, because there whatever the levels are, for each level we will be having a for each level we will be having a value. So that means h level means h values. So let's add O of h for the later loop that is used to store in our answer. And as for the time complexity, and as for the space complexity, we'll this was about time complexity, and as for the space complexity, we will be requiring O of n for recursion, and we are also using a map, right? So that will end up taking a map that will end up taking only h levels. So let's say O of h, and then also we are using a vector to return our answer that will also store h values. So that is also O of h. So this will be our time complexity and space complexity. This O of h is for the map, sorted ordered map, and this is for the vector that we will return as our answer. Okay, so this question can also be solved by using level order traversal. And compared to DFS solution, level order traversal solution is much easier to understand and code as well. So let's try to understand what how will that work. So in level order traversal, what we do, if we try to write its level order traversal, we will having 1, 2, 3 and 5, 4, right? And we only need the later values like this one, this one, this one. So we can either what we can do is we can store the level order traversal, and then we can create a new vector, and in that vector for every level we can just take the last value of every vector in the level order traversal. By which I mean, let's say my LVL is having the level order traversal, then I am saying that for every vector that exists in this level, for every vector that exists in level, you just store answer dot pushback v dot back. So you are just storing the last value and then you return your answer, so that is also a valid solution. But if we are wasting so much space like storing these extra values, so we shouldn't do that. What we can do is when we are traversing through the level, and before traversing a level, we can take a value, let's say x, and initialize it with anything, doesn't matter, and let's say -1, and then you traverse this thing, and whenever you are processing a level, you just keep updating x. So here in this case, x was a -1 initially, and then it becomes 1. Then you store 1 in your answer vector at the end of processing this level. And also when you are, so now you come to this level, and when you are processing this level, you will be having your x initialized with your initial value, that is -1, and then you update it with 2, and then you process this, then you make it 3. Now this level is done processing. Now you store this 3 in your answer. So your answer got 1 first, then it will get 3 first, and again then you come to the very next level, and then you try processing it. You will be having your x, which will get updated to 5, then it will get updated to 4, and you will store 4. And that's how you will get your answer directly. You don't need to store whole level order traversal. So let's see its code. Now it is very similar to you just need to change small things in your level order traversal code. So let's make this font a little bit big, 16px, right? Okay, so for doing a level order traversal, we need a queue. So we'll make a queue, and keep in mind that we need to take the type to be tree node queue, and then I push the root to it. Also I'll make a vector int answer, that will be having my final answer. And now how do we do level order traversal? We do while not queue.empty, I'll keep processing, and I will take the size. Now queue.size will give me the size of this level. So initially it will give me 1 for this one, then it will give me 2, and depending on how the tree is given, it will give you the size of the current level that is you are going to process. And now I'll try to process the level, but like I said here, before processing the level you can take any value, and now I'll take a value, let's call it x, and I'll take it as -1. And now I'll try to process my level I less than 0, I less than size I plus plus. Now I will get the topmost element in my queue, so that is stored, let's call it node queue dot front, and then I'll pop it off, and then I'll update my value with the value of this node. After doing so, you don't need to anything, just update the value. It gets updated every time, so it will end up, so after processing a level, it will end up having the value of the very last node of that level, so which will help us to get our right side view. It will update every time, right? And now we push the left child and right child if they exist. So if node left exists, then we will push that in our queue. Also, if we check if our right exists, will push into our right. And here we need to take care that we only push our left child first and right child later, because for a given level, let me show you. For a given level like these two, like for one, these two are a child, and you end up pushing this in queue first, and this will be pushed later, and so this will be processed first and this will be processed later. And your values, so we will be having, while processing this level, we will be having x as -1, and then it will become 2, then it will become 3. Or if you push 3 first, right node first, and then you push the left node, you will end up having your x will be -1, and you will end up having 3 and then 2. And this is not this is not something you want. You want 3 to be there. So that is why I pushed the left child first. And like I said, after you are done processing that level, you just store that x into your answer. And so yeah, after the traversal is over, you can just return your answer. So let's try to run this. Okay, I haven't considered a condition wherein, this was a test case that I missed. So if your root is not there, if your root is null, then what should you return? You should return an empty vector. So let's try to run this. And now let's submit it. And it is working fine. Let's think about the time complexity for this. We are doing a level order traversal, and we are only using doing a level order traversal. So that means we are going to every node only once. That means O of n time complexity plus there is nothing else. Time complexity will be O of n, and for the space complexity we are taking a queue, right? And what is the maximum size that the queue can take? What is the maximum size queue can take? Queue can take maximum size depending on the width of the depending on the number of childs present in a level, right? So like after processing a level, you are left with the childs in that queue. So if there is a level which is having many childs, so that number of childs will be the maximum space that the queue will occupy. So I'm considering it to be a full tree, and depending on that, I can say that the width of the tree will be the time complexity, will be the space complexity, will be the space occupied by the queue. So that will depend on the width. Q will depend on width. So let's say O of width, right? Plus we are taking a vector which will storing the values which will be equal to the height, whatever the levels are there. And let's say the height of this tree is 3, then we will be having only 3 values in our answer. So O of W plus O of H will be the space complexity for this. So yeah, thanks for watching.